So here is the perfect tool for this job. This is called an arbor press. And we're not going to do this on the arbor press, but I do want to show you the setup. We're going to do it with a tool that you probably have. So let's take a brushless motor. This is a brand new Himax, one of my favorite brands. These are very good quality for the money. And let's reverse it so that we can mount it from this side and drive the prop off of this side. This is a common procedure, and a lot of people don't know how to do it properly. It's very easy to strip the fasteners out. And the problem that we have is people overseas that are putting these motors together, and most people in general, do not know how to use Loctite products properly. There's way too much Loctite on this fastener. If I were to put this wrench in here and try to force this fastener loose, there's about a 50% chance I would strip it. And there's 3 of them that I have to loosen. The one in the collar, and then one in the back here, and here. So how do we solve this problem? Well, here is a little micro torch. A fancy cigarette lighter that blows a flame will work really well too. And what I'm going to do is I'm going to warm this up, but I'm not going to make it super hot. I'm just getting it warm. Probably too hot to touch, a little hotter than that. And what we want to be careful of, we don't want to boil the grease out of the ball bearing that's in the front here. And this piece here has the magnets in this black band. We want to warm this up too, but we don't want to get these magnets up to high temperatures. If you get these magnets up to a couple of 100 degrees, they can demag and become less powerful or be completely ruined. And as far as I'm concerned, if you do something to damage your motor and cause it to have less power, it's completely ruined. So here we go, and this is going to be an actual time, and hopefully you can see on here, there'll be a little moisture. And I'm going to heat, I'm going to put the tip of the flame, you probably can't see it, but I'm going to put the tip of the flame like right here, and I'm trying not to let it lick in here. I don't want to burn anything here, and this is one of the reasons why I have a very small torch, so I can control the flame. And so the blue flame is licking out to where it's just touching the tip of the shaft. Now I don't want you to heat the tip of the shaft, but I wanted to give you a comparison. Now notice the moisture. You see that moisture, like a little white cloud that was on the wheel collar. Back it up and look at it if you want to see it. I've got about the tip of the visible blue flame right here on there. And that's probably enough. I'm going to put the wrench in. Okay, it needs a little more. There we go. Didn't take very much force at all. Now, an important clue here, don't touch the tip of the wrench there, it's hot. An important clue here, there's a notch in the shaft. So I have to turn the set screw out a few turns. If I just crack it loose and then try to push the wheel collar off, the tip of the screw will gouge the shaft and damage it. So we want to be careful of that. I have it almost completely out. But it's still in there enough that it won't fall out on us. So this area is a little more sensitive because it's what the magnets are nearby connected to. But for some reason, it's also generally a little easier to get the set screws out of the aluminum than it is out of the wheel collar. The wheel collar is generally made from brass, and for whatever reason they stick in there better. Okay. So I can feel that heat coming up into here. It's almost too hot for me to keep my fingers on. So that was probably more time than I needed. Now there's no damage at this temperature. If you can hold your fingers on something, it's 130 degrees or less. And that's a safe temperature. And both of these screws broke loose real easy. And there's really no point in me rounding off a wrench or stripping out a screw by let me just be lazy and try it without using the proper procedure. That's what most people do. We'll be smarter than most people. Okay, we've got those backed out fully well. Now, we're going to move the shaft. Now the shaft is not only held in position in this back plate with the set screws, it's also held in position with a press fit. That means that aluminum hole may be slightly smaller than the shaft, but another problem is when they overuse this Loctite, they put a drop in the hole and run the screw in. There's way too much. The screw kind of acts like a piston and pressurizes the Loctite and squeezes it around any gap between the shaft and the back plate. So it takes quite a bit of pressure to initially get the shaft to move. Now we can pull. I want to show you another important feature here. There's so much to learn about such a simple job. I'm putting this wrench in the screw just so I can have something to hold on to. There we go. Right here is a little tiny ring. Do you know what that ring is for? This is the ball bearing. There we go. See that little ring there? And it's kind of loose. I don't know if I'm moving it. Yeah, you can see it move maybe a little bit. So the purpose of that ring is to keep this wheel collar from touching the face of the ball bearing. We don't want to lose that. If you lose that ring, then the face of the wheel collar will be rubbing on the ball bearing, and that's friction. And friction is not making us fly fast. So we've got it all loose, and I'm going to pull the motor apart just so you can get a good idea of how it's put together in case this is your first time. And our little ring fell off. Right here it is. There's another spacer in here, and it's this nylon one right here. We don't want to lose that either. And that is likewise to keep the boss here, this area here, from rubbing against the face of this ball bearing. The only part of the ball bearing that spins is this inner ring here. The shield and the outer race are locked together, and there's a teeny little gap between that inner ring and the shield. So that's what these spacers are for, to hold our appliances, or to hold our stuff off of the ball bearing so we don't have any friction. So don't lose these little parts. Now it's not necessary to pull this motor apart to do this procedure. So I'm going to put it back together. And you want to be very careful about getting metal in your motor. There's no metal here on this bench. It'll get in there on the magnets and just really foul things up. How do we press this shaft through? There's a couple ways to do it, and we want to avoid doing it with a hammer. Got the spacer on here, and I'm setting the wheel collar at the tip of the shaft. So I put the screw down on the flat like that, and then I opened it up just a little. Now I'm sliding it out to the tip of the shaft, and now I'm going to tighten it. And you can see this is snug, and this is how much more is tight. About like that. Okay? So I went from here to tighten it. And we're ready to press that through. Almost. Let me show you another trick. I've already done 2 motors, and here is a socket. This is a, what is it, a 3/8 socket, a Craftsman 3/8 socket. I've put a piece of tape on the socket, and this socket will allow us to support the motor but push the shaft down into the hollow of the socket. Now the reason I have the piece of tape on there is I don't want to mar up this anodizing on the back of the motor. I don't want to scratch it, and the end of the socket is chrome, which is very hard, and a lot of times there's little abrasions in it, and it would take that blue right off of there. So now I've got something to push it into that won't mar the surface. So here is the perfect tool for this job. This is called an arbor press. And we're not going to do this on the arbor press. But I do want to show you the setup. We're going to do it with a tool that you probably have. And that's basically the setup. And I would pull down on this handle, and through a gear ratio here, a rack and pinion gear, I have a huge advantage. And this one can produce 1 ton of force to push on the shaft, which will move it easily. Now let's go to the tool that you probably own that can do this job. Here's my small shop drill press. And look, we can press with a drill press. Let's get this set up to do the job. Now I want to push on the middle of the table, but we have a hole in the table, so I'm going to put a piece of steel there. Socket, do I have room for the motor? Oh, a little lower. Now I should have room for the motor. So now I've got a little bit of pressure on it. I'm going to make sure it's square and vertical. I'm looking at it from this side and from this side. And I'm going to push on the handle. And there it moved. I had to put quite a bit of pressure on it. And notice the shaft is starting to protrude through the back. Once we get it to move initially, it'll move easily. So we're going to push that all the way down flat, remembering that we have our little tiny spacer ring there. And there it is, it's all the way down. And you can see there's a gap between the wheel collar and the bearing's pretty flush with the face of the motor. So hopefully you can see that gap in there that was preserved by the ring. And here we have our shaft coming out the other side of the motor now. So now we can mount the motor back here. But before we do that, we have to tighten our set screws down. And a lot of people can damage their motors here because they don't understand what tight is. So I'm going to demonstrate that so that you can see it. And this is a long wrench, which gives me a lot of torque. A Bondhouse wrench, so it's a good quality American-made wrench, not expensive. So there's where the set screw hits the shaft, hits the bottom of the shaft. And I'm going to hold it like this so you can see how much tighter, and you can see a little bit of flex in the wrench. See that? The wrench is flexing. That's as tight as that needs to be. And we got the one over here, which is actually the one that's going to hit the flat. There's another flat in here. There's several flats on the shafts. One of the reasons I love this brand of motor is parts are readily available. You can buy every part for it. And RadicalRC.com and other dealers who sell these motors stock all those parts. So there we go. We've got this one flat. We've got this one seated out, and that's tight enough. So the other one took about a quarter turn before it got tight. This one only took a half of a quarter turn or an eighth of a turn to get tight. And let's see, we already tightened this one, but I'm going to check it. Oh yeah, that's tight. So there you go. I hope that helps. You can reverse these shafts in these motors very easily. There's all the proper procedures, everything you need to know to do it absolutely correctly, not make any mistakes, not strip anything out, and you don't have to worry about it. It's an easy job. You can change them back and forth as many times as you like. Don't be afraid of it. Get out there, fly, have some fun. And these principles can be used for other things in the shop you need to press together or apart. Now, I wouldn't want to put any more pressure than that on a drill press. It's not really made for those kinds of forces. So an arbor press is a good investment for your shop. This has been Dave on the Crafted channel. We'll see you on the next video.